Okay, 3.3, increasing and decreasing of the function and the first derivative test. Well, have we been doing first derivatives already?
Yes.
Yes. So we're going to add another meaning to what a first derivative can tell us. Oh, I love it. It just wants to make me do this. Okay, the definition of increasing and decreasing of a function, just so we are clear, from left to right, values, if y values, oh, I got too many values in there. Okay, from left to right, if y values of a function are declining, then the graph is what? Decreasing. Okay? If from left to right, the y values are growing, the graph is what? Increasing. We know this. We have a point at which a graph is neither increasing or decreasing, which would be called a relative min or max, correct? Okay, at a relative min or max, the function is constant. We have intervals of increasing and decreasing. So on this graph right here, it is from negative infinity to where? Negative infinity to where? To where? Zero. It is what? Increasing. From 0 to what? 1. It is decreasing. And from 1 to... It's increasing. You notice I'm using parentheses, yes? Yes. Because at 1 and at 0, this function is doing nothing, isn't it? Right. So what we're going to be doing is using that first derivative to find where a function is increasing and decreasing, and at the point which they change, is that going to be a relative min or max? Yes. Okay, again, we've done this stuff before. Now we're just putting a little different spin on it, so we can use it for more things. You guys let me know when you're good to go on. Andrew, you good? Mm-hmm. Okay. So, theorem 3.5, testing for increasing and decreasing of a function. This condition has to apply. It's applied every single time. The function has to be continuous on the interval AB, inclusive, yes. It has to be differentiable. So, can it have a peak? No. Like, if at the peak is where you're looking, then we have issues we got to deal with another way. Okay. Number 1 says, can somebody tell me what this statement says? And it's going to click because I didn't put my pin on. Can somebody tell me what this statement right here says?
F of x is greater than...
Not f of x.
The derivative of f is greater than 0 for all values in x, y.
Or ab, because, not xy. This is...
No, it wouldn't be the same as x, y would.
No. Because AB is an interval, we're only talking x's. These are intervals, and intervals are only x's.
Yeah, but what does the parentheses mean?
Uninclusive. In between.
So they're also intervals?
Yes.
Whoa. I don't know why I didn't know that.
Okay, intervals are only x values. Up here, this interval is inclusive because it has square brackets. Yes. Down here, the interval is uninclusive because it has parentheses. If it was xy, it would be xy. Does that make sense? Okay, but what does it mean if the derivative of x is greater than 0?
And it's increasing.
Yeah, but what does that mean? It's a positive number, okay? So if the derivative of x is greater than 0 on this interval, so we're going to do interval analysis like we did last year. This graph is increasing. Yes?
Okay, so in number 1, AB is also an interval?
Yes.
Why? Wait.
Okay, now let me go through it again. I'm going to read it again and explain as I go. If the derivative of x is greater than 0, meaning it is positive, all values between a and b, okay, it is positive for all values between a and b. Is it talking about a and b?
No.
No. Okay, then F is increasing from A to B inclusively.
Okay, I'm just asking about how.
The square brackets?
Yeah.
The square brackets mean it includes the endpoints. The parentheses means the endpoints are not inclusive. That's the only difference between those two. If they were XY, it would say XY, not AB.
Okay. So
Okay.
only when it's AB are the intervals only X values.
All intervals are always X value. When you are talking intervals, they are always.
Like if I've got 1, 0, that's.
Yes,
But I
if
thought
you.
one was a X and one was a Y.
If it is an interval, listen
Is it
what.
tell me if it's an interval?
No, because that's all you talk about is intervals.
Okay.
Okay, you're talking about a coordinate.
Yeah.
Okay, an interval and a coordinate.
Looks the same.
It does, but you're talking about two different things. So as of now, you're talking about, unless it explicitly says that is a point on the graph, then it's probably going to tell you the interval or the point. It's probably going to tell you. Does that make sense?
So confused.
It's one of those, but
How would you know?
it's one of those things when you just deal with it more, you just know. And typically now, I'm never going to give you an XY. I'll give you an X, and what do you have to do? You have to figure out the Y. Does that make sense? Because we talk so much about what X is doing on a graph because Y just comes along with it. Okay? So if it's less than 0, then guess what it's doing? Decreasing. And if it equals 0, then it's what?
Constant.
Constant. All that really kind of makes sense?
Yes.
Okay, so tell me when you guys are ready.
Yeah, I'm going to erase this because that's kind of.
Okay, oh, here's a picture just so you can see, but I think you get decreasing, increasing, and constant. But and remember, the derivative is related to the what of the function? The slope. Yes? So if the derivative is less than 0, the slope is what? Less than 0. It's negative. So that means it's going down, yes? If it's greater than 0, it means the slope is going what? Up. Because it's positive. Now, the next slide is directly out of the book, but I would not expect you guys to write every little word. Okay? Are we ready? Oh, this isn't. Sorry.
Okay.
This is an example. This next slide that has a list. Okay, it says find the intervals of increasing and decreasing. So what do I have to find? Say it.
The derivative.
The derivative. Okay, so find the derivative of that. So, do you have 3x squared minus 3x? Okay, so we need to set this equal to what?
0.
0. I would assume you're factoring out a 3x, yes?
Yes.
So you have x minus 1. So x equals what and what?
1 and
and
1
and
third.
0.
1 and 0. Please write them littlest to biggest. 0 and 1. The reason why you're going to write these littlest biggest because we're going to make a chart. Okay? The chart is going to have over here, it's going to have the interval. Probably today I'll write interval, and after that it's going to say int, because I don't want to write interval every time. Okay?
So it's a one-sided chart. Not one-sided, but we don't have to leave a larger amount of room on those.
We will probably leave something over here eventually, but not today.
Okay.
Okay, this chart will get bigger and bigger and bigger as we move along. Okay, now, I put just test here. Sometimes I just put X. This is the value we are going to test. I will write test value for today. Because when we did interval analysis, I always wanted you to tell me what number you were throwing in there, correct?
Correct.
Okay. And then I'm going to write f prime of x, and we're looking for just the sign of it, positive or negative, because that's all I care about, right?
Right.
And then we're going to have conclusion.
How's that different from the sign column?
What?
How's that different from the sign column?
The sign is going to be positive or negative, and what's our decision from that? That's going to be our decision. I typically don't write conclusion, I write decision, because what is this telling me about the graph? Right now I'm phrasing it the way the book is phrasing it. I like decision better because it's why I'm making a decision what the graph is going to be doing, because what this is building us to is graphing. Okay? We will have a first derivative test, we will have a second derivative test, we will have multiple tests that happen in this chart. So we will have all sorts of conclusions about increasing, decreasing, concavity, max, min, zero, all that will happen in this chart. So our charts will get pretty big. Okay, so our interval, this didn't state, it did not give me any interval, did it? Did it give me a starting interval? So if it didn't give me one, where do I always start?
0.
Nope.
1.
Negative infinity?
Oh.
Yeah?
Oh, yeah. That's been a while.
Okay, so I also do not write these as inequalities. The book does. I think it's a waste of my time. And I'll show you what I mean by inequalities. So I have negative infinity to where is my first critical number? We didn't identify that, but that's a critical number, right? What's my first one? 0? Okay, that's why we write these in order so we don't have to think about it later. Okay, then we leave 0 and we go to where? To 1. We leave
The
1.
next one. Positive infinity.
This seems kind of familiar.
Well, it should.
Somebody tell me you've done something.
Okay, so in between negative infinity and 0, let's pick a number.
Negative 5.
Negative 5. Okay. Now, do you want to just pick numbers now or go across and then come back? Go across and come back.
No, pick numbers.
Okay, so between 0 and 1.
0.5.
Okay, between 1 and positive infinity.
5.
5. Be reflexive. Awesome. Okay, so I want the sign. So all I'm doing, and it says sign of f prime.
Negative,
So where,
positive.
yes, where am I plugging it into? The original or f prime? Prime, because it says prime,
Yes.
right?
Yes.
Okay, so we're plugging it into here. I like this one just because it's broke down and I have to do less math in my head, right?
Right.
So
We're putting the sign.
we're just putting the signs into our f prime, and I'm doing it the factored. I could put it into the original, but would I have to do some more math in my head? Yeah, and we know how that goes.
So would it be negative 3x minus x plus 1?
Why would you get plus 1?
That would be negative 3x.
We're plugging it right into here.
Are we plugging negative 5?
Negative 5, because that's the x.
I thought we were just putting the negative sign.
No. Okay, you had me scared. Okay, when I plug in negative 5, 3x gives me a negative or positive.
Negative 15.
I don't care about 15. Negative.
And then x
Times
times negative 5
Another
minus 1, which is
negative.
another
negative, and so I'm going to get a what?
Positive.
Positive. And I circle my positives because that's my answer, right?
Yes.
Okay, we're going to go to the next one. 1/2. Maybe this won't be so rough. 3 times a half, positive or negative?
Positive.
Times a
Negative.
negative. So my whole answer would be a
Negative.
negative. 5.
Positive. Positive.
And so the whole thing is
Positive.
positive. So my theorem 3.5 tells me this graph is what?
Positive.
No.
Negative.
We're increasing or decreasing or constant. So what is it?
increasing.
Increasing.
Sounds like a lot of times.
Okay. Next one.
Decrease.
Decreasing.
And then increasing.
And then increasing.
So it's just the word. Right? That's all I want.
Yep.
I hope it doesn't get any harder than this.
Well, not today.
I Right.
We've just been building. I mean, we really, did we do? Okay, but other than we just added the interval analysis today, but have we honestly been doing that already?
We know
Have
it's
we
gonna
been
get hard,
plugging,
though.
have we been plugging X's in and getting Y's out?
Yeah.
Yeah, you've already been doing the interval analysis. I just didn't tell you what you're doing.
And something seems too easy.
Okay,
Yeah.
ready, go on?
Yes.
I'm scared.
Okay, so this just, now stop. This just tells you what we just did. What did we
don't
just
write
do?
it. We wrote
Found the
interval,
interval,
test
tested
value,
the value.
sign of.
Okay, we found the critical, I always touch it without putting it on my pen. We found the critical number. How?
By finding the derivative and setting that equal to
Okay,
0.
so critical number was derivative of x equal to 0. Also, where are critical numbers at?
Endpoints.
No.
No, max and mins, max and no.
X.
Asymptotes, yes, undefined. If there is a asymptote that occurs in there, is that going to be a critical number? Yes, you haven't had many of those occur, but they will occur. Okay? Determine the sign. How did we determine the sign?
We plugged in the
We tested the interval. And then we used theorem 3.5. Says if it's positive, it's what? Increasing, negative,
Decreasing.
0.
constant.
Okay,
How would we get a 0 out of that? You wouldn't?
it would be something else. It would occur some other way. Okay, so these guidelines are also valid for interval AB is replaced by the interval of negative infinity to, did we just do this?
We did.
We did.
We
We
probably don't even have to write this.
we didn't know. You probably don't. But this is in the textbook. This exact, remember when I put a big old block around there? I want to put those things in there because we do need to remember that we can learn from the textbook and we don't need to write down everything. We just need to write down the basic steps that come out of it, correct? Now, a function that is either increasing or decreasing over the entire interval, so if it just looked like something like this, which would be increasing the whole time, it is called strictly monotonic.
Can't speak.
Monotonic. Yes.
But isn't it constant at some point?
No, it is not. It appears to be constant, but it is really never constant. The rate of change just extremely decreases.
Okay.
Functions like that, they are not unless you're putting in like probably a composition of functions.
Okay.
Okay, it's very hard to get a function that is completely constant unless it's a composition of functions. Okay, are we good with this? Okay, so we are going to talk about the first derivative test. Now I just need you to think about this, okay? We can use the interval work to find relative extrema. It says, number 1, again, what is all this saying? Oh, I touched it again. All this up here is saying it has to be continuous, it has to be differentiable, all of the same stuff it's always said, correct? Okay, so it says if f prime changes from negative to positive, meaning from decreasing to increasing, what is the point between those two? Decreasing to increasing would be a what?
Constant.
No, it would be a minimum.
Oh, yeah.
Decreasing to increasing would be a minimum. Okay, what about increasing to what? Decreasing would be a maximum.
Okay, that first one.
The pictures help.
Right, but
The saggy.
here, is that better? Let me add some more to it.
I don't know.
I don't know.
Oh, now you just added another one.
Okay, just stop. Okay, but this, if it's going from negative to positive, then it's a relative what? Minimum. If it's going from positive to negative, it's a relative maximum. And we're not going to write relative. We're just going to say min, max. We know that we can have more than one. That's all that means, correct?
Right.
Now, if both sides are negative, then it's neither a minimum or maximum. That makes sense, correct?
Yes.
Okay, it means you probably put a point in there, or it could be an excluded value that was a critical number, correct? So if there was an asymptote, could they both be the same on both sides? Yes. So we can use this to tell me whether something's a relative min or max. So that's the only next part you're going to do. We're going to do the exact same thing, and then we're going to evaluate our conclusion and tell whether it's a min or max. Okay? Tell me when you're ready, because we just have examples now. these chunks that we're doing this in are very minimal. We are building, so I said it's important to do them every day. And please don't leave your homework till Sunday, guys, because what's going to happen?
You're gonna forget.
You're going to forget it all. And this isn't that hard. I want it to be cemented in there before. Am I good?
No,
Can I have
absolutely.
just one more?
Yeah, just give me a minute.
Was I supposed to write something because I didn't write?
That's fine.
Yeah, same.
I-
Saying what I already.
I would just quick. I mean, it's in the book. If you want to go
I'm
back
just a
and get it
slow
out of the book.
writer. Like, honestly, I'm not even writing on it. I'm just really slow writing.
For me, it takes more to think about what I'm about to write.
Yeah.
And honestly, if I was sitting in here, I'd probably be doing the examples, but leave everything written until I would go home and rewatch the video. Because it would take my brain from writing.
Yeah, just paraphrase the last one. That's probably what I should be doing.
Yes, that's what you should have been doing
I
the
wrote-
entire time.
I wrote a negative sign to positive sign equals minimum.
Yep.
Positive to negative equals.
As long as you put derivative there, yes. Because it's of the derivative, the first derivative. Because, again, we're going to be adding some second derivatives in there. Am I good now?
Yes.
Riley? Okay. Okay, so, and these are just pictures, but I couldn't fit them all on one slide unless you wouldn't have been able to see it. Okay. Oop. God darn it. Okay, down here at the bottom, it says definition of a critical number. I'm just reminding you, because you already know that is, yes, where the derivative is equal to 0. Also, this would include x-intercepts or vertical asymptotes would also be critical numbers. Okay.
New information?
The vertical asymptotes, we've said where it's undefined before. But if you want to include that, if you want to state that critical numbers are where the derivative is equal to 0, x-intercepts, and vertical asymptotes, that might be like maybe a list you want to just make.
Wait, what are we supposed to be writing?
Critical numbers are where the first derivative is equal to 0, x-intercepts, and what? Vertical asymptotes. And vertical asymptotes are what makes the denominator 0. So if there's no variable in the denominator, is that applying to the situation? No. Now, x-intercepts are something that I have added as a critical number because they are important for us to look at and acknowledge their existence. Some people would say they're not considered a critical number. I think it's very important to know where an x-intercept is. Sorry. They do have some things. Okay.
Wait.
Oh.
Okay.
Okay. Okay, so I have find the relative extrema. So we're going to do everything that we did, and we're going to add another step to our conclusion. So f of x equals 1/2 x minus sine of x from 0 to 2 pi, and then 0 and 2 pi are not included. How do I know that?
Those are in
They're in parentheses.
What's that mean?
What do you mean? They're not included in the interval. It's like an open circle. It just stops there. Okay, so the first thing I need to do is what?
Derivative.
Derivative. So find the derivative. You guys working on that derivative worksheet I gave you?
Yeah, I've got part of it done.
I don't have one.
Come class once in a while. Get one before you leave. Okay, did you get 1/2 minus cosine x?
Yes.
Okay, then I do what?
Hold on. I got
Equal it to 0. So you get cosine of x equals 1/2, yes? Okay, so I need to ask myself, where is cosine 1/2 at? I'm going to have two answers because it's between 0 and 2 pi.
I don't know how you figure this out.
Unit circle stuff.
Well, I would say obviously I am in a 30, 60, 90 triangle, yes?
Oh, obvious.
Why is that? Why am I saying obviously? Because
One and two.
it's 1 and 2, yes? So we have 2 and cosine is 1, right? It's adjacent. So if this is 1, 2, what's this one have to be?
It has to be not 2, it has to be 1, right? No?
Square root of 3.
Yeah.
Square root of 3.
Yeah.
So what angle is across from square root of 3?
Another 60.
A 60, so pi over 3. So pi over 3 is my first one, yes? Okay, cosine is x. Where else is x positive? What quadrant? Fourth, so I'm 1 less than 2 whole pi with 3 as my denominator. 5 pi over 3. Okay, I'm going to continue to give you these trig ones because they will eventually be there. Okay, so you have to keep working on them.
I got some worksheet of trig ones.
Wait, what?
Okay,
Enough.
so our interval is we're going to do our interval, yes? And then we're going to do,
INT.
yes, you can just write INT. What's our next one going to be?
Test
Value.
Test value, and I typically just put an X. But it's our test value, yes?
Yes.
Then next,
Sine of f prime.
okay, and again, I'm just going to put F prime. Actually, on our real ones, we're going to have F, F prime, and F double prime. Because we will test things in all three functions.
We are no.
Okay,
Conclusion.
Oh. Yes.
conclusion.
Boom.
Okay, so where's my interval going to start?
Negative infinity.
No.
0.
0. Why is the 0 now?
It's positive.
Well, no, because I gave you an interval this time.
Oh. Zero.
But it's still 0. Okay, I gave you an interval this time, so it starts at 0. Oh, and I'm just going to tell you guys, after we write this one, remind me, I will tell you how the book writes them. Okay, 0 to where? Pi over 3.
Then pi over 3 to 5.
Just a second. In the book, if you look at Calc chat or whatever, it's going to 0 less than x less than pi over 3, and that is annoying to me to write every single time. We know that this is an interval. We know it's non-inclusive. Let's just write it that way. Okay?
Why would they waste ink?
I don't know. They can't waste ink to make something a real fraction. I don't know why they would waste ink on this. I don't know. Okay, then we leave pi over 3, and where am I getting these numbers from?
From our
Interval and our
The
critical number.
critical numbers. Okay? So what's next? 5 pi over 3?
And then 5 pi over 3 to infinity.
No.
She understood. She was just a little. out there.
Forgot about that.
Forgot about
Interval. Yeah.
Come on, pen.
I understand it all now.
Come on.
Nah, just kidding.
I have to coax the pen to work. Okay. So I need an angle between 0 and pi over 3.
Pi over 4.
How about pi over 6?
Whatever.
Pi over 4 is big. Pi over 4 is bigger than.
No, it's not.
Oh no, it's not. We can do pi over 4. Never mind.
Oh.
My brain went pi over 6.
Good job.
My brain was telling me it wasn't.
Pi over 4 isn't.
Pi over 4.
Pi over 4 is bigger. Pi over 6 isn't.
Yeah. No, pi over. I want littler. I want littler than pi over 3.
Pi over 3 is 60 degrees.
Yeah, and 45 isn't. I know. My brain was just telling me that pi over.
Pi over 6 is 30 degrees.
Right. So 30 is littler, too. My brain, when I did it, just did 30.
Okay.
I would
Okay.
actually like to do pi over 7,530.
Please.
Okay, how about pi for the next one?
Sounds good.
I
Okay.
actually kind of wanted 4 pi over
4 pi over 2 is 2 pi.
That's
Not even close.
2.
Okay, next one.
6 pi over 3.
No, because that's
No,
2 pi.
That's 2 pi.
5.5 pi over 3.
No.
No, wait. I
11
wanted to
pi
do
over
it.
I'm sorry.
How did you do it?
Gosh.
Well, it's 30. It's the only one smaller than. Well, it could be 45. We could do 45. You guys
No.
want to do 45 again?
No.
Yeah.
Or do we want to practice our
It's gonna be
different?
7 pi over 4 if we do 47.
You guys want to do? How do I know? Well, you have to have. If I'm in the fourth quadrant and we have 60, this is 60 away. Yes.
Yeah.
So you have to be either here or here to be between 5 pi over 3 and 2 pi. So you either have to have 7 pi over 4 or 11 pi over 6. But we're going to go 11 pi over 6 just so we can
No,
mix
I feel like
around
we
what
should-
our...
I think we should stay with the 40.
I don't think so. Okay,
No.
so where are we going to put pi over 4 at?
I don't know.
To the
X.
Nope.
the
What's their thing say?
cosine x equals half. The function.
We're going to
The
put it in right here. I'm going to put it in right here because of what is my heading?
Yeah, but don't you put it in
That.
for X?
Yes, but I want to know which function.
Mm.
Okay, so if I put pi over 4,
Positive.
it's going to be the cosine of pi over 4 is,
Positive.
what is it?
2 over square root of 2, which is going to be square root of 2 over 2.
Okay, so it's the square root of 2 over 2. Is square root of 2 over 2 bigger than 1/2 or less than 1/2?
Less.
Plus.
It's bigger.
slightly bigger.
Because what's the square root of 2? Is it bigger than 1?
Yeah. It has to
Yes. So it's going to be a little bit bigger, right?
What is
So-
the square root of 2?
It's like 1.3 something. Okay.
How is that possible?
So I have 1/2 minus the square root of 2 over 2. So is my answer going to be positive or negative?
Negative.
Negative. Okay. So then I have pi. What is the cosine of pi?
-1.
And a -1 times a negative is a,
Positive.
and a positive plus a positive is a.
Positive.
Wait. Oh, never mind.
Okay. 11 pi over 6 is 1/2, yes? The cosine of 11 pi over 6 would be
I
1/2?
don't know where you get these numbers.
Wait, would that be 1/2? No, it'd be square root of 3. Because 11 pi over 6 would be pi over 6, yes? And this would be 1 square root of 3, and this would be 2. So it'd be square root of 3 over 2. So is square root of 3 over 2 bigger than 1/2?
Yes.
Yes. So it's going to be what? Negative. So if you've got to have a piece of paper off to the side or whatever that you're working these things out, then you got to work them out. Is it going to be beneficial to you to get back to where you were with them?
Yeah.
Yes.
You should have been.
I was,
Yes.
I was
Okay.
behind in the first.
Negative. Increasing or decreasing?
Decreasing.
Decreasing.
Increasing, decreasing.
And I usually just put DECR. Okay,
If I just put D, C, D.
sure. And what's the next one?
Ink.
Increasing
Ink.
and
These.
decreasing. Okay, so now this graph is decreasing and then increasing. So right in here is a what?
Minimum.
Minimum.
Which is what that
And that would have to be at pi over 3, wouldn't it?
Yes.
At pi over 3, and that wouldn't be an interval, that would be the next, wouldn't it? At pi over 3, it is a minimum because what is this graph doing? Decreasing and then what? Increasing. And at 5 pi over 3, it is increasing and then decreasing, so it is a
Max.
max. And there's nothing in here, and there's nothing in here. There's no spot where there's no test for this. So if you read your chart, you guys have this nice, I didn't tell you to skip a line for that reason, but should you be skipping a line in between those?
Wait, so what's
Now
the
Yep.
I know that.
What is the difference?
Okay, can you not yell, Riley, please?
I didn't yell it.
Yes, you just did.
I just said, what is the difference?
What is the only difference we did?
Around the min and max.
It's the only difference.
Is that all we're doing today?
Mm-hmm.
Are we done?
Yeah, unless you want to do more examples, I got 2 more.
Yeah.
I think we're good.
Okay, what's the only thing that's going to change about these?
You have to mark minimums and maximums.
Right, and you're going to have derivatives. Would you like to do one not trigonometric?
What's
Like,
Not with sine, cosine,
yes?
and
Jump.
okay, you want to do that one? Or do you want to do that one?
That one.
Okay, one's a quotient rule and one's a chain rule, I think.
Not that one.
Okay, so f of x equals x to the fourth plus 1 over x squared. It's the first thing you have to do.
Find derivatives.
Then do it.
Hold on. So if it's x squared squared, that's x to the fourth. Then you multiply. Right?
I don't know what you're talking about.
Like the denominator squared would be x to the fourth.
Yes.
I did mine different because I took an x out. Wait. No. Oh, yeah. That's not what I had.
That's not what
I had 2 times 2x squared minus x to the fourth minus 1. Is that what you had, Sadie? Over.
Did you have this part?
Yeah. Then I took out a 2x.
Mm-hmm. And then you're left with 2x to the fourth minus x to the fourth. So that would be x to the fourth. And negative 1.
Why is it negative?
Because it's a negative out here. So it has to be distributed through the quantity.
Yeah, but I know where I messed up.
Okay, so now I do have the first derivative. This one's going to be fun though. To find the zeros, is this a perfect square right here?
Oh my gosh, I got that.
Yes.
Yes.
Square.
So when I factor that, I'm going to go down and I'm probably going to have to erase them. I'm going to have x squared plus 1 and x squared minus 1, correct?
Correct.
And it's going to be equal to 0. Can I factor the x squared minus 1 again?
If you want it. Yeah.
Well, is it a difference of squares again?
Yes.
Yes? So I have x plus 1 and x minus 1. So now I need to go find all of my zeros.
Just one.
Okay, this would be x squared equals negative 1. Would that be a real solution? No,
Yeah.
so that's not a 0. This would give me positive and negative 1, correct?
Correct.
So I have x equals plus or minus 1. But did we start with a fraction? Actually, let's go to our derivative. Do we have a fraction with our derivative right here? Do we have an excluded value in there? Because I said extrema with no intervals, so I'm going negative infinity to where? Positive infinity. Do I have a problem with that denominator?
Yes.
What? It can't be what? It can't be 0. And the only thing that would make x cubed 0 would be what? 0. So we have another critical number at 0. So these are my critical numbers. Remember, I told you to remember that excluded values are also critical numbers, aren't they?
Yes.
Okay, so we're not going to have time to finish, but I want to set up our intervals, okay? So, where does my interval start?
-1. Or negative infinity.
Negative infinity. To where?
To -1.
To -1. We're going straight across the number line. So -1, leave yourself a gap, because you're going to have relative min and max, right? -1 to what? 0. 0 to what? 1. 1 to positive infinity. Are we good with everything else that's going on?
Mm-hmm.
Is this going to be the key to getting everything right?
Yes.
Yes.
So, are the assignments still the same as what's on the board? We just added the worksheet too?
Yeah, the worksheet was just an extra practice for